Okay, so now we've been working with balancing equations. We've been working with writing from words. And so now at this point, you are ready to start predicting the products. These questions will look like this. Write the equation, balance the equation, and predict the products for the following. So we have magnesium and nitrogen, and I can start by making some little notes that this is Mg, and this is not going to have any charges or anything. This is going to be N2. I have two things, and I have two things that are elements. The only thing that they can do is combine. I can't single replace, I can't double displace, there's no compound. I can't break them apart, they're already elements. I can't combust them because there's no carbon. And so what I'm looking at is synthesis, put them together. The biggest mistake is you're going to take this and go MgN2, I'm putting them together. But I always have to go back to writing the proper formulas. So Mg is plus 2, N is minus 3, and so I'm going to make Mg3N2. So my overall equation, which I'll put the next one so I know how much room I have, my overall equation is Mg plus N2 yields Mg3N2. That's a synthesis reaction, and once it's done, now I need to go back and I need to balance it. So just grabbing another color here. I have one Mg, I have three Mgs, and I have two Ns, I have two Ns. So my Ns are good. It just looks like I need to go ahead and balance my Mg by putting the 3 there. And so that one is good to go. Copper 2 oxide, Cu plus 2, O minus 2, is decomposed, sometimes there's a hint there, into its elements. So I'm going to be breaking it apart into copper and to oxygen. Copper 2 oxide, I write as CuO. And I know I'm breaking it apart and I'm breaking it into its elements. So its elements are copper. When it's over here and it's by itself, it has no charge. And then oxygen, and what's special about oxygen, which is the same thing that's special about nitrogen, okay, is that they're both Hunkelbrief. So they need that too. Hunkelbrief and Hunkelbrief needs that too. Now that I've written all of my pieces, so I have a synthesis and then I have a decomposition. Now that I've written my pieces, I need to balance. So I have 2 oxygens. So I put a 2 here, 2 oxygens, 2 coppers, 2 coppers. And let's take a look at a third one. Chlorine and potassium bromide. It's chlorine, it's by itself, it's a Hunkelbrief, so it's Cl2. Potassium bromide is K plus 1, Br minus 1. Here I have an element and a compound, so I need to recognize that this is a single replacement or single displacement reaction. So I'm going to need to replace one of these elements in the compound with chlorine. Chlorine is in group 1 with a -1, so it's going to bump out bromine. I can't put chlorine and bromine together because they're both negative. They're both halogens. So I have Cl2 plus Kbr, which is then going to bump out that bromine and make that Br2. And then K is going to combine with chlorine, and I know that K is a plus 1 and Cl is a minus 1, so we're going to end up with KCl. Now again that I have all of my formulas written, I can go back and balance. So I have 2 Brs, so I'm going to do 2 here. I have 2 Ks, I'll do that here. 2 Cls, 2 Cls, and my equation is balanced. Here are 3 more, and I want you to try. So what I want you to do is pause the video here. I know they're ones that we haven't necessarily talked about. These are double displacements and combustion, but give it a try. See if you can get some of the things down on paper, and then we'll come back to seeing how you did. Okay, so I'm going to ask you to pause your video here. Okay, good. Hopefully you tried these out. Let's see what you got, because you could certainly write this part. Ca plus 2, hydroxide, OH minus 1. Sulfuric acid, H plus 1, and SO4 minus 2. There we go. So I'm going to go ahead. I have compound and compounds, which means I'm going to have to put those compounds together and just flip-flop them. So in this case, what I'm looking at is compound plus compound. I'm going to take this guy and combine him with this guy. I'm going to take this guy and combine him with this guy. And so I'm going to have CaOH2 plus H2SO4, which is going to make CaSO4 and then HOH. HOH is also H2O, which is water, but for these kind of equations, it is fine to leave it as HOH. In fact, it makes it easier to balance. Sulfate and sulfate is balanced, but I have two OHs, so I need to come back in here and put a 2 here, two OHs, and I have two H's, and that balances my two H's. So there I'm good and balanced. Iron 3 chloride and sodium hydroxide, Fe plus 3, Cl minus 1, Na plus 1, OH minus 1. So let's put this together again, compound and compound, so it's a double displacement, FeCl3 plus NaOH. And I'm going to perform a double displacement, which means again, this guy will combine with this guy will combine with this guy. So Fe goes with OH. I have to make sure I use my parentheses. FeOH3 plus NaCl. I go ahead and look to balance. I have 3 OHs, so I'm going to put a 3 here. I have 3 NAs, so I'm going to put a 3 here. I have 3 Cls, so I have 3 Cls, and then 1 Fe and 1 Fe, and I'm good. Methane is combusted in air. Oh, and this one's going to get you because you don't know the formula for methane. That would really be hard for you to do. So you probably were looking at me saying, Mrs. Kerr, you don't know what methane is. I would have to absolutely tell you that methane is CH4. I'm sorry, there's no way that you would know that. In any combustion reaction, you have what you start with. They are always plus O2, and they always produce CO2 plus H2O. I have 1 carbon, 2 hydrogens, 4 hydrogens, and so 2 times 2 is 4 hydrogens, 2 oxygens and 2 oxygens, so I need to come here and put it 2. I'm sorry about not telling you what methane is. That would absolutely be provided for you to be able to do this reaction. So we'll be practicing tomorrow with predicting our products, but you can see it's very similar to what we've been doing. You have to recognize what type it is and think about what that ultimately looks like at the end.